Hello there, let's continue to learn about Kubernetes. So in this tutorial we will learn about configuration, so updating configuration via ConfigMap. If you would like to learn what is a config map, you go in the concepts, in the configuration subsection and the config maps. Here you will get like more deep dive of what they are and what options can be used to create them. As you remember before, I was using Minikube, and I would like to show you also the available Kubernetes playgrounds because they are nice. You don't need to install anything on your computer. I will use Code Cloud. So here you can choose the version of the Kubernetes, and here is like you will get access to it for 1 hour. You can use it as a tutorial playground, which I will do right now. I have 32 because I have run it before and I have been reconnected to the session. If I'm doing get namespace, we can see that we have some namespaces. Great, so let's go to tutorial part. So I will zoom it a bit and fix the... Yep, great. So let's first create a config map. Okay, create config map. This is a shortcut. The name of the config map, sport, and from literal. We can create it also from files, but in this case it's from literal. Football. We can check get config map. So we have this config map and we can describe, okay, describe config map sport, and we will get the following data, which is the key and value. Great. Also the config map has like binary data, which is encoded, I think it's called binary 64. Base 64, sorry, base 64 format. So if you would like to indicate the binary data, it should be already encoded. Now we will create a deployment, and here you can see that the deployment has the config map volume name. It has 3 replicas. It has this label, and in the spec subsection we have a container. We have only one container, which is an Alpine labeled 3 image. It has the following commands. It will shell, and this is flag minus -c will interpret the following string as a command. While true, echo the date and my preferred sport is, and cut the etc config sport file. Then sleep 10 seconds and done. Expose the port 80, and here we have volume mounts. Here we have definition, like we specify that we in this pod we have the following volume config map, and it's a type of config map, so we are indicating here the name of it, and inside the pod we can, or the deployment to be more correct, we can refer it with this name, config volume. So here in the volume mounts we are mounting this volume, so we are referring to it using this name, and the mount path, this is the path on which the config map will be available inside the container. etcd slash etc slash config. So here it will be created a file when the volume, it's config map, it's mounted as a volume. For each key, like the data, here we have key, it will create a file with the name of that key. So here is the export, and the file will have the football. This is the data inside the file. So we can create this deployment And here we are creating from remote source, from this file. Let's do it. Get deployment. Deployments. Yeah, we have the deployment and it's up and running. So now we can get pods, and we can select which pods we would like to use by specifying the selector. And this selector, where it's coming from. In the definition of the deployment, we have this selector in the spec subsection. So we have match labels. So basically this is the key and value. We would like to get all the pods which have this key value selector. And here we have it. Great. Now here we have some additional information. On each node where one of those pods is running, the kubelet fetches the data for that config map and translates it to files in the local volume. So this will be one file for each key in the data section. The kubelet then mounts that volume into the container as specified in the pod template. The code running in that container loads the information from the file and uses it to print a report to standard output. You can check the report by viewing the logs in the pod of the deployments. Okay, so let's. I have clicked again on that link. Okay, get. Basically, we want to get the logs. So logs deployment config map volumes. So here we have the logs, and like each 10 seconds we are getting a new log. Since we are looping here, we are looping and sleeping. 10 seconds we can see like 38, 48, 58, 08, and so on and so on. And that's great. Now we can edit. Okay, edit config map. Yeah, autocomplete here, it's very tricky. In this environment, I will do config map as a shortcut. This is the name of the config map. Sport. Here we have it. It uses a V editor, so yeah, some tricky shortcuts here to be used. And now we can see that the data was updated from football to cricket. Let's do it. Actually, I would update it to volleyball instead of cricket, and the rest I will leave it as it is. To exit here, I will press escape and semicolon WQ. So write the data, which means save, and quit. And voila, it went it. Okay, because we have it edited. So now if we are going k logs deployment config map volume, so follow, which is kind of watch analogy, is just getting the streaming of the standard output. Let's wait a bit. Okay, unfortunately there is nothing. Okay, get config map sport, and let's describe it. So we have it. So that's interesting. Okay, finally. It took some time. Actually, like under the hood, the deployments are updating the config maps, but they have some timeout to do it, like each 30 seconds by default, I suppose. And when we are mounting as a volume, it's refreshed after this period of time. So we have to wait a bit until we are getting the new value. So that's great, we have it. Now we have some extra information. Config map is mapped into running pod using either a config map volume or a projected volume, and you update that config map. The running pods is update almost immediately. Yeah, almost. That's a good question. Good word. Projected volume. What a projected volume is? A projected volume. It's if we would like to mount more, let's say 2 or 3 config maps, and mount as one directory, as a one mount per our container. So it's kind of a proxy. That's called projected volume. Great, so first objective is done. Now let's go to the second. Update environment variable of a pod via config map. So let's create a new config map. Okay, create config map, which is called fruits, from literal fruits equal a pulse. Okay, get config maps, and we are having this new config map created. Below is an example of deployment, so let's look at this deployment. Map env var has 3 replicas. We have this label selector. It has the same image, but now we are not mounting the volume, but we are referencing it using the env inside the container directly. So we are referencing using, we want inside the pod to have access, to be represented as a fruits name of the variable with the value which coming from config map key. The name of the config map, it's fruits, and the name of the data inside that config map, it's fruits. So here we can okay, it means, yeah, the name, because the name of the config map is this one, it's the key, and the name of the data itself, key data, is this one, and the value apple should be value of this variable fruits equal apples. Here we have the same loop, and let's apply this deployment. Okay, deployment, got. Okay, here we have the second deployment, and var. And we can get the pods of this specific. So now it's coming handing this selector, because we will not get all the pods, but we will get the pods only of this deployment, which we have them right now. Now we can go, yeah, and here one thing I forgot to mention, we are printing now the value of the fruits environment, which expected to be the value apples. Let's log the data, and we have it. Great. Now we will edit cm fruits, and we will change what they want to mangoes. Let's change it to mangoes. I know, actually I'll go with banana. Yeah, banana is the best. So, okay, describe cm fruits, and we have our banana fruit. Now, if we will log, and I'm using arrow up to get the history of the commands, and down to scroll from them, and yeah, let's add this follow flag. Follow. And here we are getting that the output remains unchanged even though you edited the config map. And yeah, that's the caveat. When we are mounting it through env, like this, we will not get the update value. Only when it's mounted as a volume, it's automatically updated. So if you would like to get this update, we will have to roll out, delete those existing pods, restart them. So here we have this command. Okay, roll out, restart, deployment. This is the name of deployment. And we will use this flag. Okay. Didn't want it. Okay, so it's not rollout status. Okay, we have the status. It's successful. Okay, get deployment. Oh gosh. Get deployment config map and it's running. Let's get those pods. We see that the deployment has been created 3.5 minutes ago, but we have restarted it. And now let's get the logs. Okay, logs, deployment, config map. And we have banana, which is great. It means the value in that environmental variable referenced in the config map was updated. Great. Now we will go to the next section, update configuration via config map in a multi-container pod. So let's create a new config map. I will clear the terminal. Okay, create a config map called color with one L from literal. The literal, it's color red. Okay, get cm config maps. We have this new config map. Okay, describe cm, and we have this data. Okay, so here we have a deployment. The deployment is called config to containers, and it has 3 replicas. It has the following label for selector, and it has volume definition. We have 2 volumes, a shared data volume, and which is mounted as empty dir directory, and config volume, config map, which is our config map mounted. And I have 2 containers. Here is the first container, and here is the second. First, it uses an Nginx image and mounts the shared data, this volume, and it will be available inside the container under the user share / nginx / html. And we have the second pod, which is an Alpine image, and this mounts both volumes, share data and config volume, and we have the following command: shell interpret as a command this string, while true echo the date, my preferred color is, and we cut the etc config color, and we write this output to the pod data / index html, and do it each 10 seconds. So we are getting the data from the mounted config map. Here we see etc config map mount path color, the name of the file, with the value red. And this data will be written to the share data, pod data in index.html. Great, let's create this deployment. We have it, clear the terminal. So let's get the pods with the following selector. And we see here 2 from 2, each pod. So we have 3 replicas, each replica has 2 pods. So that's why we have ready 2 from 2. Here we will create a service. If you remember from the previous lessons, the service is a way to expose an application running a set of pods as a network service. So it's a proxy which exposes outside one static, almost static, let's say like that, IP address, and it's proxying that traffic incoming and outgoing to the services behind which are the replicas of the deployment based on the match selector label. Okay, let's expose the deployment. Config expose will create this service for this deployment. The name is ConfigMap to containers, and we are passing here the name of this service, the port on which it will be listening, and the target port. Target port. Okay, and we can see get as we see. So we have the ports. The target port is the port. Yeah, here's like some. This is the port exposed by the service. We can see it here. But the target port is the port which is exposed by the container. So Nginx inside the container, I suppose it will listen to port 80. So this is the port of the ports of the pods. Excuse me. Great. Now we will use port forward command. And here is tricky. I don't know if it will work. It should, I suppose. Service config map. So we are mapping internal to external, and we have this end, which means hang on. No, sorry. This, if I would run without this ampersand, the command will be blocking, but this runs in a separate process, kind of a daemon in the background. And we can see that, okay, we have run it and forward from 8080 to 80. Now, let's open a new terminal. Okay, can get, just to check, we have those configs maps. So let's curl localhost 8080. And we are getting a lot of HTML, I suppose. So let's go to the head. Oh, gosh. Yeah, it's a lot of HTML. It should see the output similar to. Okay. I cannot see that output. But I see a bunch of JavaScript. Interesting. Let's try something like, and from it, let's grab my preferred color is red. And we see nothing. That's very sad. Okay. Interesting. What we can do, it's let's exec into that pod get pods, and here we have exec. We are executing interactive the pod to containers. And we are running inside using the shell. Great, we are in Alpine. Default container is Nginx. We have 2 containers here. So let's list the content inside the pod data. Let's actually cd pod data. Okay, let's see. There is no cd etc config. Okay, that's interesting. At least can we cut etc config color? No such file and directory. Okay. Okay, so this is the Nginx. Yeah, it makes sense because we don't have Nginx any of those. We have in Nginx the user. Let's cd user ls. So we have cd share Nginx HTML. Let's cut index HTML. Okay, so we have it. Here we have it, this desired output. Okay, let me open and try to curl again. Okay. That's interesting. Okay, yeah, this is not my local environment, and it's interesting what's going on here. But we can see that indeed the output is written here. Forward localhost to port 80 inside. Okay, I will skip this to not make this video longer. Let's suppose that we got it. Yes, let's do some ConfigMap editing. Okay, edit CM color, and I will edit. Here we see green. I like the green color, so I will do the same. I will press exit, semicolon, write WQ for exiting, and we have edited. Okay, describe CM color, and we have green. I'm still inside the shell, so if I will do cut, I'm inside. This is the pod of Nginx. we can still see the same output. Okay. Loop over the service URL for a few seconds. Cancel this when you try to. Okay. So we have to wait some time, and this is a desired output. Since I am getting that, I think it's something misconfigured here. I will just wait a bit and try. Okay, great. So after some more than 10 seconds, we got this updated color. Because it's mounted as a volume, it updated automatically. Whew, great. Not perfect, but working. Update configuration via an immutable config map that is mounted as a volume. So immutable config maps are especially used for configuration that is constant and is not exposed to change over time. Making a config map as immutable allows a performance improvement where the kubelet does not watch for changes. Yeah, so as I mentioned, this volume mounting, it's refreshed, like the kubelet is doing some extra work. It's checking, let's say, each 30 seconds. And if you have a lot of config maps mounted as a volume, this is overhead. So if you have like not modified frequently config map, it's a good idea to make it immutable. So it will be like less resource consumption from the kubelet. Because in different project can be like 1-2 config maps, in other can be thousands, and that's a lot of work for the kubelet. So if you do need to make a change, you should plan to either change the name of the config map and switch to running pods that reference the new name. So change the name of config map and switch to running pods that reference the new name. Okay, interesting. Yeah, not ideal. Replace all the nodes in your cluster that have previously run a pod that used the old value. Yes, interesting. And restart the kubelet on any node where the kubelet previously loaded the old config map. So yeah, because this is immutable, you will need to do a lot of restarting, recreation, dropping old versions, deleting the old pods and creating new one. That's it. An example manifest for immutable config is shown. So yeah, the only new configurations here, immutable semicolon true. So create the immutable. Let's create this immutable. So we have the company name Acme. Let's exit from this pod. Let's kill this port forward. Let's create this config map. Okay, get config map. So we have company name, and you can see this name. It's correct. Now below is an example of deployment mounted as volume. Okay, they will kill my lab. Okay, a directory containing data accessible to the pod, to the container in a pod. So basically this is a volume, a directory. So here we have the deployment. The name immutable config volume. It has 3 replicas, match label. Okay, we have one container. It has image Alpine labeled 3. We have this while true, do echo, and cut the value of the company name. File, sleep 10 seconds, and we mount the volume. Config under this path, and here is the definition of the volume, which is taken from config map. So let's go and deploy it. Okay, so here we can get the pods of this selector. We have them. The pod container refers to the data defined in the config map and uses it to print a report to standard output. You can check this report by viewing the logs for one of the pods in the deployment. So here we have the logs. Yeah, this is the company. So here we have a note. Once config map is marked as immutable, it is not possible to revert this change nor to mutate the contents of the data or the binary data field. In order to modify the behavior of the pods that use this configuration, you will create a new immutable config map and edit the deployment to define a slightly different pod template referencing the new config map. So yeah, we have to create a new one and change the reference. No modification in place. So let's create a new config map. So basically it has different company name. Oops. And something is going on here. I'm not getting hey, are you working? Okay, get config map. Okay, interesting, it was freezing. Okay, that's cm. So we have okay, with the ending 12. This is the new config map. Has been created. Now we are editing the deployment. As usual, this is bad autocomplete. Edit deployment. Called immutable config volume. Here we have the volume. Let's go to the reference of the config map. Here we have it. In the volumes section, we have the name, and here is this prefix, suffix actually, what I'm saying, prefix. It's suffix, so we can modify it. Yeah, it's tricky. Right Q. I have edited it. Great. So yeah, I have updated this field. Now I'm listing the pods and I see that a new replacement has been created and the old has been terminated. And now if I will do OK logs deployment immutable volume, we see this new name. So new config map has been served, and the old one, get config map, this one can be deleted now. Okay, delete config map and the name. And that's how it works. Pretty interesting. And here we have the summary. Okay, so looks like we are running out of time, but I don't need any more of the environment. So yeah, changes to a config map mounted as a volume on a pod are available seamlessly after the subsequent kubelet sync. Changes to a config map that configures environment variables for a pod are available after the subsequent rollout for the pod. Once a config map is marked as immutable, it is not possible to revert this change. You cannot make an immutable config map mutable, and you also cannot make any change to the contents of the data or the binary data field. You can delete and recreate the config map, or you can make a new config map, different one, When you delete a config map running containers and their pods maintain a mount point to any volume that referenced that existing config map. So you have seen that I have, following the tutorial, I have created a new config map, modified the deployment, and the deployment has created new pods which reference the new config map and then deleted the old config map. So this is the life cycle of updating the immutable config maps. And that's pretty it. Thank you very much for your attention.